Hello my dear, and on request of my viewers, YouTube channel viewers, readers, I can say I am making this video. Well, this is a case of overhanging beam. I hope you understand it, because there's a part which is hanging from I mean outside, away from this support. That's why it is known as overhanging beam. So on the actually I have already created a video based on overhanging beam. I hope you understand what I'm saying, and but in that video I haven't include UDL means uniformly distributed load, that you can see over here. This is UDL, 20 kilonewton per meter. Okay, now what we are going to do in this question, we are going to draw shear force and bending moment. So before going to shear force and bending moment, before going to draw shear force and bending moment, we have to find out first reaction force. Okay, I'm just extending lines because it will be easier for me and for you also to understand the question on how to solve such type of problems. Okay, first of all I have to find out RA plus RB. I mean, on these two supports how much load is acting. So this is a point load, so point load is equal to 10, plus this is another point load 20. This is UDL. So total load acting on this span would be 20 kilonewton per meter into 2. That means 40 kilonewton. How much it will be? 20 plus 10 plus 20 30, and 30 plus 40 70 kilonewton. There is no need to use calculator till now. Okay, now what I can write the equation, that is just I'm going to write here only. So what we can what I can write, RA into 2 plus 2 plus 2, that means 6. Sorry, I have to just if I am fixing this one, then the movement would be happen here, but I am taking from here to here the distance, because the another support is here. RA into 4 is equal to 20 into 2, because point load is 20 and distance is 2, that's why 20 into 2. Another one thing is there, this is important. If you haven't watched my all videos of SFD and BMD, then you need to put concentration then on the next step what I am going to share with you. Okay, now as usual I have to write plus sign. Okay, so what I have to do here, I have to first multiply these two. That's why I can find out the total load, that is 20 into 2. But distance, whenever in the case of UDL, we always take as the total load on this beam as a concentrated load on the mid span of this total UDL. So total UDL is 2 meter, the mid span would be in 1 meter. So 1 meter here, 1 meter plus 2 plus 2. I hope you understand. Another thing is here, because this side we always take positive, you know that, but this side would be negative. So 10 into 2, I hope you can see, yes, 10 into 2. So after calculation what we can get, 40 minus 20, 40 plus 120 minus 20, this is 140. So 3 4 12, okay, 40 kilonewton. So R is equal to 140 upon 4 is equal to how much? 2 2s are 4, 270. So this is 35. So RA is 35 kilonewton. If RA is 35 kilonewton, then it is obvious B is equal to 70 minus 35 is equal to 35 kilonewton. Okay, I hope you understand the solution I have just find out. Okay, now what it is easy to draw shear force diagram right now. we are going to start we are going to start drawing from this side. Suppose that from here to here is 35 kilonewton, but again we can see that the UDL is acting here. So what will happen, that it would be linear line. Okay, so 40 minus 35, how much? Minus 5 kilonewton. 40 minus 35, how much would be there? Minus 5 kilonewton. Okay, now here is another line, that is 20, so this will become minus 25 kilonewton, and here we don't have any load, that's why it would be like this only, that means straight line. Again, because minus 25 is here, that's why 35 we are having reaction force 35 here, so we need to add here, so therefore here 10 kilonewton. Now therefore we don't have any load over here, that's why it will be straight line. Okay, I hope you understand how how I can able to draw these lines. Okay, now let's move to the next step. Okay, now I have started from here, so I need to draw, or I need to start drawing bending moment diagram from here. Okay, but one important thing, I don't know the distance from here to here. This is important. This is 5 kilonewton per meter, sorry, 5 kilonewton. Okay, so how to find out this distance? Most of the time we got, or we usually get question on this topic, on this type of question, or this type of problem we usually face, and we don't know how to solve such type of problem. Okay, let me share with you how I can able to find out the distance here we are using. Now we are just subtracting from 35, and how much we require to subtract to the shear force diagram will be on this reference line, 35 exactly. Okay, now come to here, 1, that means 20 kilonewton per meter is at per meter. Okay, so that means 1 meter is equal to 20 kilonewton. So 1 kilonewton is acting 1 by 20 meter. 35 kilonewton 1 by 20 into 35 is equal to how much? Let me share with you. 35 divided 20, how much? 1.75 kilonewton, meter. So the distance here to here is 1.75, therefore this will be 0.25. Now what I have to do, first of all tell me, let me tell you why I have calculated this distance, because I have to find out the area of this triangle. That's why I need the distance from here to here. Okay, now you know the area of the triangle is half base into height, so half means 0.5 base 1.75, height is 35, so how much? 30.625. Again let me tell you, this is positive side. If I am taking as positive side, then this will be like this. So let me this here. So if this is linear, then this will be like parabolic. Okay, now I have to calculate the area of this triangle. Okay, so what will be there? The same formula I have to follow. 0.5 into 0.25 into this height is 5. Okay, so 0.625, so this is 0.625. okay, 0.625, and what we have calculated earlier, 0.5 into 35 into 1.75, so the remaining would be how much? 30. And my dear, always try to write its unit and try to make it a little bit bigger, because I don't have much space. That's why I need to like just end size. Okay, I hope you understand. Okay, now we need to solve two things right now, only two things, that's it. So how much here, how much we got? This is 25 the area would be that this is a rectangle, right? So this is 25 and this is 2 30. 25 into 2, not 30, it's 50. So this is the area we are finding out. Okay, now what will happen, this is negative side, okay, and this is in positive side. We have to subtract it, and if I will subtract minus 30 from positive 30 plus 30, how much remaining? Minus 20. And because this is straight line, therefore bending moment would be a linear. So this would be like this. Suppose that this is 20 kilonewton meter and in minus side, okay. Now what we have right now we have 10 kilonewton plus distance is 2 meter. So again we need to find out area of this rectangle, right my dear? Okay, but again my dear, this is in negative, this is in positive, so we need to add together. Plus minus 20 plus 20, how much? 0. One more thing, this is straight line, SFD. If SFD is straight line, then BMD would be linear and this would be 0. So this is the bending moment diagram. This is the bending moment diagram of this overhanging beam. Well, I hope all of you understand the concept behind the concept I have used to solve this question. Well, thanks for watching. Hope to see you again in my next video. Bye bye.